All right, so let's refresh our memory on exactly what molecular compounds are. All right, remember they are two nonmetals. Okay, if you don't have out your periodic table right now, go ahead and get that out. All right, because we are going to want to be able to look at our periodic table a lot today. All right, when we look at our periodic table, hopefully you are looking at the ladder and you can tell me that your nonmetals are to the right of the ladder. All right, so if I'm looking at those nonmetals, something you might notice is that we don't have a whole lot of them. Okay, the majority of your periodic table are metals. Okay, so when we're talking about our molecular compounds only consisting of nonmetals, we actually don't have that many combinations of molecular compounds that we can make. Okay, here's the deal with our molecular compounds. Because it's two nonmetals, we don't need to worry about the charge. Okay, no charges. We don't have to balance out the positives with the negatives. We don't have to make a neutral compound. And so you might be saying to me, well, how are we going to figure out what the subscripts are in the formula? Okay, and that's where these prefixes come into play. Okay, we have prefixes for 1 through 10 here. Honestly, friends, 1 through 5 are the most common ones. We'll run into 6, 7, 8, 9, and 10, but they're just not as common as 1 through 5. Okay, you might have heard some of these prefixes before in other settings. Okay, most people have definitely heard of tri before for 3. A lot of you have heard of probably penta, like pentagon. And then octa is another like really familiar one probably for 8, like octagon. And so you don't have to have these memorized. I would give these to you on a quiz or a test, or you can access them obviously on your own at home. But they are the 10 prefixes that we're going to use. Okay. All right. So let's go ahead and look at an example, and we'll kind of try to figure out, kind of deduce here how these things are getting named. So for instance, the compound carbon dioxide. We're pretty familiar with that, right? We are all exhaling that a heck of a lot right now because our brains are working really hard to listen and focus and learn. And so that means our body's using energy. And when our body is using energy, we are going to be exhaling out a lot of carbon dioxide. Okay, if you were to go for a run or a walk this afternoon because it's going to be beautiful out, you would also be exhaling a heck of a lot of carbon dioxide then as well, because your muscles are going to be working really hard then too. Okay, carbon dioxide. So let's take a look at this name. Something that I notice is I see this prefix here, right? And I recognize that stands for 2. So, okay, that makes sense because of the 2 subscript here. What I notice also is the lack of a subscript on the carbon, which means there's only one of them. And I also notice a lack of a prefix on the carbon element name, okay? The last and final thing I notice is that the second element ending is still IDE, right? That's a similarity between molecular and ionic. All right, so let's take a look at the rules here now that we've kind of worked through an example. The rule is write the name of the first element in the compound using the prefixes above, unless, there's always a but here, right? Unless there's only one, don't use mono, just the name. Okay, so that makes sense now as to why we have 1 carbon in carbon dioxide, right? There's no subscript written on there, so we assume that it's a 1. And that means we don't have a prefix on that carbon, okay? My friends, this is the only time you're not going to include a prefix is if the element, the first element, there's only one of those, okay? For the second element, you are going to use the prefix every single time, even if there's only one on the second element, okay? You are still going to use the prefix. You are going to also change the ending to IDE, just like we've been doing with our ionic compounds, okay? Pretty straightforward because we don't need to worry about subscripts making charges neutral or balanced, okay? So I have another example here. The carbon dioxide example is here as well, but we have carbon monoxide. So notice again, there's no prefix on carbon because there's only one of them. On the O, right, that's the second element, I'm changing the ending to IDE, pretty familiar with that. And I'm also adding the prefix on the second element. Okay, you will always have a prefix on the second element. All right, my friends, any questions or concerns on any of these rules here that we just went through before we take a look at some examples? No? Everybody's okay? All right, so let's dive into some of these examples, okay? I'm going to lead us through these just so we can kind of hear these things and see how we're going to add these prefixes in, okay? So for CBR4, what I notice is that the first element, there's only one. So I'm just going to write the name of that element, and then C is carbon. For BR, I know that's bromine, and I know the prefix for 4 is tetra, and I need to change the ending to IDE, so I am thinking tetrabromide. Okay, so my final answer there for CBR4 is carbon tetrabromide. All right, let's take a look at letter B. It says N2P3. So the prefix for 2 is di, so dinitrogen. Remember, we don't change the name or the ending of the first element, right? We just add a prefix if there is more than one as the subscript. And then for 3, we have a prefix of tri, and then phosphoride. Okay, again, changing the ending of that second element to IDE still. Dinitrogen triphosphoride. Okay, for letter C, we've got 1 P and 3 Cls. So we'll start this off with just phosphorus. And then the prefix for 3 is tri, and Cl is chlorine. So we'll change that ending to IDE, so we come out with phosphorus trichloride. All right, for letter D, we have ICl, so we have one of each, first element and second element. So for the first element, we'll write it out just as it is on the periodic table, iodine. And then we need the prefix, so we'll start with mono and chloride. We have to change that ending to IDE, so iodine monochloride. All right, next we have N2O. So we have to start with dinitrogen. And then we have one oxygen, so monoxide. Dinitrogen monoxide. All right, last but not least, we have SiF4. So Si is silicon. We don't need a prefix on there because there's only one. Now for F4, the prefix is tetra. So tetra and fluoride. Tetrafluoride. All right, guys, any questions on A through F there? I'm hoping that you are agreeing with me that this is a little bit easier than our. You just have to think about a little bit less here, right? We don't have to make a neutral compound. We don't even have to look at the charges, okay? All right, so let's jump down to, we'll skip over 2. We'll come back to that. I'm going to have you guys work on that in a second. But let's skip down to number 3. And I'll go ahead and do number 3 for you. And then I'll have you guys work on 2 and 4. And we'll come back together and check those out together, okay? I want you guys to have all of these examples before we sign off today. All right, so phosphorus triiodide. My favorite thing to do is to write the formulas for molecular compounds because I think it goes by so quickly, especially if you've got your prefixes right in front of you, okay? So phosphorus triiodide, so there's no prefix on my phosphorus, okay? So that means there's only one of them. And then tri is 3, iodide is I, so Pi3 is my formula there. All right, silicon, excuse me, silicon has no prefix, so it's just going to be Si. Tetrachloride, tetra is 4, chlorine I know is Cl, so I come up with SiCl4. All right, dinitrogen, so we've got 2 here, so N2. pentoxide. So pent is 5, so N2O5. All right, letter D is dinitrogen again, so that's N2 again, tetroxide. So tetra is 4, so we've got N2O4. All right, last but not least, we've got carbon monoxide. Because there's no prefix here, I know there's only one. And then monoxide, that means one as well. So we come up with the formula of CO, carbon monoxide. Okay, guys, questions or concerns on A through F here? Okay, here's what I want you guys to do. I want you to go ahead and work on number 2 here. And you're going to be writing out the names there. And then I want you guys to work on number 4 here. I'm going to go ahead and set about 5 minutes on the timer. I think should be a good enough time. And then we'll come back together and we'll answer those. We'll check those answers out together. Okay, 5 minutes on my timer here for number 2 and number 4. About 1 more minute left, guys, to finish off 2 and 4. All right, guys, let's go ahead and talk through 2 and 4. All right, anybody want to offer me up the name of GEH4, number 2A? I got germanium tetrahydride. All right, N2BR4. I got dinitrogen tetrabromide. You probably see what I mean already, that like 1 through 5 are the most common prefixes, right? And the most common subscripts. Okay, letter C, diphosphorus. Pentasulfide. SiO2 is selenium dioxide. NH3 nitrogen, no prefix because there's only one of those. And then trihydride. And then silicon dioxide. What I got for letter F. Any questions or concerns on those? All right, let's take a look at number 4. We have to write the formulas here. All right, so carbon dioxide, CO2. There's no prefix on carbon, so that means there's only one of them. Sulfur hexafluoride, so SF6. Again, no prefix on sulfur, so it's just 1. Hexa is 6. Dinitrogen, so N2. Tetra is 4. Chlorine is Cl, so N2Cl4. Carbon tetraiodide, so no prefix on carbon, so just 1. Tetra is 4, and I is, or iodine is I. Phosphorus pentafluoride, so phosphorus is P. Penta is 5, fluorine is F, so PF5. And then diphosphorus, so P2 pentaoxide is O5. Any questions or concerns on number 4, A through F? Everybody feels pretty confident with this? All right, guys, so let's take a look at your assignment for today. It is the mixed naming practice, okay? And here's the deal with this. You have to be, careful when things start to get mixed up. And what do I mean by mixed up? Well, I mean, if I just give you a whole list of compounds, the first thing you need to do is to identify which ones are molecular compounds, okay, and which ones are ionic compounds, all right? And that's what I'm going to have you do for the first 2 pages here. So let's take a look at the first section here. It says write I for ionic or M for molecular for each of the compounds listed, and then write the name of the compound, okay? So what I need to have out is definitely my periodic table, because I need to be able to find these elements on the periodic table and say, this is a nonmetal and this is a nonmetal, so that makes this molecular. Okay, and then I need to look at number 2 and I need to say Mn is a metal and Cl is a nonmetal, so this is ionic. Okay, for number 3, I have CCl. Carbon and chlorine are both nonmetals, so this is molecular. For number 4, Ni, that's a metal, so this has to be ionic. Number 5, SiF4. Si and F are both nonmetals. They're to the right of that staircase, so this has to be molecular. Okay, another tip that I would advise you to use, right? If you're spending the time finding the elements on the periodic table, why not also identify, oh, Mn, let's put a star by that because it is a transition metal and will need a Roman numeral. Okay, oh, Ni, that is a transition metal. So let me put a star by that because it will need a Roman numeral. Okay, if you are spending that time really working through the compounds before you start to jump into naming it, you are going to have a greater success at naming them accurately. Okay, any questions on the process that you're going to take here for identifying if it's molecular or ionic? All right, so you're going to do the same thing for the second section on the first page. The only thing that's different this time is that you're given the names, okay? And then you are going to either write M or I on these lines here. All right, and then once you have that figured out, you are going to go ahead and write the formula on the second lines there. Okay, the second page is identical to the first page. You are going to do the same thing. You're going to identify M for molecular or I for ionic, and then you're either going to write the name or write the formula. Okay, third page is a little less intrusive, but it is still kind of the same idea here. You're given 14 names. They include ionic compounds. They include molecular compounds, and they include acids. Okay, I think there's only 3 acids, number 4, number 10, and number 11. On your test on Friday, I am going to keep your acids separate. Okay, they will not be intermingled with your ionic and molecular compounds. Okay, I think acids are difficult enough by themselves, so I'm going to keep them separate. Okay, so for these, what you're going to want to do, even though it doesn't ask you to label them M or I, or A for acid, you are going to want to take the time to figure out, okay, this is ionic. I need to figure out the charges on the ions and then balance this out before I write the formula. Okay, or if it's molecular, all I have to depend on are the prefixes, and it goes by pretty quickly. Okay, so you have 14 of those. Last but not least, friends, I just threw on 8 acid formulas. You're going to practice writing the name for these 8 acids. Okay, we want to keep those acid rules fresh in our minds because they are a little bit tricky. So we're going to keep practicing acids every single day. All right, anybody have any questions or concerns on your assignment for today? Everybody's okay? All right, guys, that's all I have for you today. So you are free to go. If you have a question